We will perform a task or a project in this video. So the development team has given us this multiple microservice architectured application. So they gave us the complete source code where one microservice is written in Python, one is written in Node.js, one is written in .NET, and there are two databases. One is actually in-memory data store and other is a database. And our responsibility as DevOps engineering team is to implement the continuous integration for this application. So we are given this entire source code in this GitHub repository. This is actually taken from Docker samples. So this application is written by Docker team, and we will try to implement the CI part on the Azure DevOps platform using Azure pipelines. So we will do it right from the scratch, understand how to write the Docker files, how to build the continuous integration system for different microservices, which has different programming languages. We will try to understand what effort is involved in the CI part. So this video is part of the Azure Zero to Hero series. We have already completed 13 episodes in this series, and this is day 14. So without any further delay, let's get started with the video. So to perform this task, DevOps engineers need to have an understanding of two things. One is the understanding of continuous integration and continuous delivery. Second thing is the understanding of this application itself. So development team has given us this GitHub repository. The name is example voting app, and the high level architecture is also provided. But we need to try this application, run it locally, and see how it is working. Only then we will be able to write the continuous integration, Docker files, and the other things. So there are steps that are provided, but let me try to explain. So this is basically a voting application where a user can actually vote between 2 or 3 options. Right now it is only 2 options. And then there is a results microservice where you can actually look at the results. So you can provide 2 options, expose it to public, and take the feedback between the 2 options, like conduct a poll, and you go to the results microservice and you can actually check the results, like how many percentage of the people have voted for option 1 and how many percentage of people have voted for option 2. So I have this application already running on my local. If you also want to run it on your local to just get a feel of this application, you can download this GitHub repository, clone it, and just perform Docker compose up. So this is the voting microservice, which I was talking about, where there are 2 options. These options can be cats versus dogs or cricket versus football, anything like that. And right now it is running on my local host. So only I can vote for this application on this application. But when we perform the continuous delivery and if we expose this to public, then we can take the feedback from a lot of people. So let me click on one of these options. Let's say I click on cats. Then, like I told you, there is this results application where this is running on a different port again on my local because I executed Docker compose up. And here it says cats is 100% and dogs is 0%. So it is technically like a polling application or an voting application. And this is one microservice. This is the other microservice. Now you might wonder, but Abhishek, what are these other services doing, right? So this is voting and this is results. So whenever you vote, this information is stored in a in-memory data store, that is Redis. And then there is a .NET application which picks this information and stores this in a database, in a Postgres database. And finally, results application, which you see here. So this application reads the details from the Postgres database. So that's why there are these components as well. So overall, the voting application is written in Python. Then we have Redis as a in-memory data store. Then we have the worker, which is .NET, which is taking the information from the Redis and storing this information in a DB. Finally, results microservice is actually reading it from the database. Now, this application is not very well architectured because this is designed keeping in mind that people can practice these kind of things. So this is not actually a production system application, but Docker team has written this particular project just to help people to build microservices related projects. Otherwise, this application can also be written in much more simpler way. But it is good for us that we get to use this project and try out things. So thanks to Docker team. Now, so these are the different microservices. We got an understanding of it. And if you carefully look at it, so this is a in-memory data store, and this is a database. So we don't need to write continuous integration or CI for these things, right? Because this is a database that is just going to be created. We can just run a Docker container for this database. And in-memory data store, Redis, we have a Docker image, will directly deploy it. But this is a custom code that is actually written. Like if you look at this GitHub repository, there are folders where this is the results microservice, this is the voting microservice, and this is the workup microservice. Obviously, these can be written in different GitHub repositories also, but these are very small microservices. They can be maintained in one project. But what we will do, we will write one CI pipeline for voting microservice, one CI pipeline for the worker microservice, and one for the results microservice. And that is how it has to be written, because these components can be independently deployed. For example, this is the results microservice that we are seeing. This can be independently deployed, right? This has no connection with other things. Like if we delete this and if we create a new version of this application, it should not disturb any other applications. That is the concept of microservices. They are independently configured, independently created, deleted, or deployed. So if you look at worker application, again to repeat, worker is written in .NET. Voting is written in Python, the one that you see here. This is Python. This is the one that you see for the results. And the results part is written in Node.js. So we will implement CI for Python, .NET, and Node.js. It's going to be very interesting, right? We are covering different things. Now, for people who don't have basic understanding of what exactly is continuous integration and continuous delivery, let me just take 2 minutes to explain this. Because if someone is watching this video, I want them to stay with me till the end and implement the project along with me. That's the main motive of taking out time and doing this project. I have a very detailed playlist if you want to learn CI/CD. I have explained right from the basics what is CI/CD, taking a lot of examples, how to answer the CI/CD related questions. Then we have CI/CD with Jenkins, CI/CD with GitLab, CI/CD with AWS, CI/CD with GitHub Actions. We have a lot of examples. And today we are going to implement with Azure pipelines. Nevertheless, let me quickly explain what is CI/CD. So CI/CD basically stands for continuous integration and continuous delivery. It's not deployment, it is continuous delivery. So continuous integration and continuous delivery. And in today's video, we are going to implement the CI part, that is the continuous integration. And in tomorrow's part, we are going to do the continuous delivery. So what is continuous integration? If you look at this GitHub repository, here there are a lot of commits, right? There are like 225 commits. And if you just scroll down and see, there are a lot of contributors who are working on this. Like there are 33 contributors. So literally there are 33 developers who are working on this particular project or application. And there are 225 changes that are made. Now, let's say this person has made a change. This person goes to one of these repositories. Let's say he goes to the results and try to modify something in the server.js. Now, how can someone understand? Like this change should not be directly merged, or this change has to be validated. Now, if this person just randomly goes here and removes this callback function, then definitely he's going to mess up something. How can we catch these things? So there is a process where what DevOps engineers do is DevOps engineers implement the continuous integration part, where any user who makes change to not just GitHub, but any version control system, a distributed version control system. So DevOps engineers trigger the continuous integration part, where The change that is made by the developer is unit tested, static code analysis is performed on those particular changes. Then DevOps engineers also build this application, run any end-to-end tests if available to make sure the changes are perfect, create the Docker image for this particular change. And once the Docker image is also created, push this Docker image to an artifactory. It can be Docker Hub, or in today's case where we are learning about Azure Container Registries. So probably the image is pushed to the Azure Container Registry. Now, why are these tasks performed? Like why DevOps engineers has to write this CI file or continuous integration where all of these things are performed. So this will give a level of confidence. If these things have to be manually verified by someone, then they are going to take a lot of time, right? If someone has to run the unit test on the change that this developer has performed, and then perform the building part, test this application, test these changes manually for the application, create the image, deploy it on a virtual machine and test it, it's going to take a lot of time. So as a DevOps engineer, we will run these things as part of the continuous integration. And as part of the continuous delivery, the new image version that is pushed to the Docker Hub or Azure Container Registry, this is taken, the new image version is taken, and we deploy it on a virtual machine or on a Kubernetes cluster. Finally, someone or automatically the deployed version is tested, and this developer as well as other people in the project get a level of confidence that, okay, everything this person has done looks great. So even if you look at this particular project, so this project has this .github repository where this project is actually using GitHub Actions. Like I told you, this is a project that is written by Docker team, and they already have the GitHub Actions. But we are going to take this project into Azure environment, and we are going to write the CI using Azure pipelines. So we will not be using these things, but just to show you, every project has the CI as well as the CD. Without that, then hundreds of people working on the project, there will not be a level of confidence on the changes that are made by the people. So they have one CI pipeline for the results, like I told you, one CI pipeline for the voting, and one CI pipeline for the worker. So you can also go to these things and understand how these things can be written in GitHub Actions, because we are not going to cover GitHub Actions in today's video. And just to mention one more thing, this thing, the CI/CD which I'm talking about, this can be implemented on the pull request, and this can also be implemented once the commit is made, right? What is pull request? Pull request is when the developer makes a change. Developers usually create something called as pull request, and this pull request is sent out to review to the team members. And during this pull request, all of these, the CI that you see here, this gets executed, and the reviewer can be confident that, okay, now I can simply review the code, because the unit test, static code analysis, build, all of these things is already verified. I can just look at the code, the overview of the changes that is made, and I can merge these changes, right? Just like if you go to this project again, and if you look at the pull request. So if someone creates a pull request on this project, let's say this one, so you can see that there are some tests that are running. Show all checks. So see here, the build and push, that is the CI is already running on this project. This is one way of running CI. The other way is you can run the CI plus CD on every commit that is made. That is, the person who is reviewing reviews and merges the code. And once the code is merged, then also we can run the CI/CD. For well-matured projects and most of the projects in your organization as well, whenever you join a company, you will see both the pull request as well as commit. So CI is implemented at both the levels, right? CI is implemented at the pull request level, and CI is also implemented at the commit level. Why? Because at the pull request level, probably you can include only some of the changes, whereas at the commit level, you can include most of the things. You can include CI plus CD at a complete level, and you can deploy the committed change on a test cluster. Now, if you want to understand more about CI/CD, like I mentioned you, just go to this GitHub repository and you can understand the complete details of CI/CD using various CI/CD tools. But for today's video, I think this level of understanding of CI is good enough, where you just need to understand what exactly is continuous integration and what are the different stages that are usually involved in continuous integration. And because we are going to create continuous integration for 3 microservices, right? Let's start with understanding how to create this Docker file for these 3 microservices, because that is very critical. If you look at the different stages, build stage, testing stage, the other important one is the Docker image creation and pushing the Docker image. And usually the build is performed as part of the Docker image itself. Previously, when the applications were not containerized, then the build stage is performed independently. Then applications are deployed as a jar or war if you're using Java applications, or an EAR, something like that. But these days, all the applications are containerized. Even these applications are containerized. So we will also perform build as part of the Docker image. So let's try to understand how to write this Docker image itself. Let's go to the repository. This is the repository. And what we do as DevOps engineers is we also have access to these repositories. And because there are 3 microservices, let's start with the first one. Let's take results as an example, or let's take voting as an example. Anything is fine. So let's start with results. So by looking at the project itself, most of the times you will understand in which programming language this particular microservice is written. Now, if I look at this, there is server.js, there is package.json, right? I can understand that this application is written in Node.js. And if you are interested, you can also read the source code. But as a DevOps engineer, that is not that much required. You don't need to understand the source code. It is the responsibility of the developers. As DevOps engineer, you need to understand the architecture and the design part. And package.json, if you want to understand the dependencies, what dependencies is this particular application is using. But my interest would be on how to containerize this application, how to create the Docker image. So when we get access to this repository, we just go to this folder or this microservice and create something called as Docker file at the root of this folder. As I click on this folder, right, Docker file is available at the root. And in the Docker file, most of the times Docker files are very, very simple, right? This is also a very simple application. What we will do is we will pick up a base image, that is Node image. Why Node image? Why not a Python image, or why not a OpenJDK base image? Because this application is written in Node.js. So if you pick up the base image as Node.js or Node, then you don't have to install Node on top of the image that you are picking up. Here I can also pick up a UBI image, or I can also pick up a Ubuntu or Alpine. But again, if I pick those images, I have to install Node.js on top of it. So I'll pick up the base image as a Node, and then I'll run this very common things. Every Node.js application, you do this, where firstly you perform the apt update if you're picking up this Node.js base image. And then you install Tiny, you install curl. For this application, curl is required because it downloads something from the internet. How will you understand this? Abhishek, how can I understand that Tiny is required or curl is required? So here, firstly, it comes with a trial and error method. And other thing is you have to sit with the development team, right? You will understand this even with some experience of continuously writing the Docker files. Like, if you miss this particular thing, the image will fail building, and then you just go back and build these things. This is not a mandatory thing. This is just to reduce the image size. So you can just ignore this one. Then as part of every Docker image, Docker file, we pick up a working directory. So here I'm picking up a working directory. Then we are using this for the local web development applications. Sorry, to run this application using a development server, we are using this. Then we copy the package.json. Package.json is the one which has all the dependencies. Now to build the application, we need the dependencies, right? So from the root level where there is package.json, this particular copy command is copying the package.json onto this Docker image. Once the package.json is taken, then what we will do is we will also copy the node modules. So node modules is again required to build the Node.js images. Looking at this, you might think that Abhishek, I don't know what is this node modules. I don't know what is this tiny. But as you keep practicing, right, you pick up 10 Node.js projects. Most of the times you will have these things in your Docker file. So it is not at all new. If someone is actually working on these applications, it's very simple to understand this Docker file. With practice, today you are looking at this Node.js Docker file. Tomorrow, when you look at the other one, then you will realize, okay, this is something that I already know. Then finally, as part of the entry point, so either you need to use the entry point or you need to use the CMD. We are executing this team, right? So using this, we will start this application. Now, let's say you don't know these things at all. Then you can definitely sit with the development team, and development team can provide you this entry point command. Development team can provide you, what are the things that are required, because while developing, they perform these tasks on their local machine. They might not be doing it through a Docker file, but they perform all of these things, right? They execute this npm, they execute the tiny. So they are well aware of these things. So you can just sit with the development team. Your responsibility would be to write this Docker file, but the steps they can provide you. With practice, you can also easily learn them. Now, if you move to the next application, which is the voting application, and this is written in Python. Now, I can easily say that this application is written in Python because when I look at the requirements.txt, this file, then I understand that this is written in Python. Or there is also this file which says app.py, where the extension is .py. Just like the Node.js, we will have the similar steps. Like here, if you see, we have copied package.json. Similarly, in Python Docker file, we will copy the requirements.txt, which is again for the dependencies part, right? And we will also have the same working directory. So most of the things in your Docker file will remain same most of the times. Like for example, the first stage, instead of Node, here we picked up Python. Second step is exactly the same, just that we don't have tiny here. Third step is exactly same. You compare both the Docker files, both of these things are same. Fourth step, previously we copied the package.json. Here we are copying the requirements.txt. One thing I'll tell you, even today, if I pick up any new programming language, let's say someone gives me a Rust project, then even I will take time to write the Docker file. But with my experience, I know that, okay, the dependencies file have to be copied. We have to pick up a working directory. There needs to be an entry point. We have to expose a port. So, these things will come with your experience, and other things is, like I told you, there are most of the things that are common. Then we have this worker Docker file, which is for the .NET applications. Just like we use the Python base image for Python and Node for the Node.js. So here we are using the .NET SDK, which is taken from the Microsoft registry as a base image. Even I haven't worked a lot on the .NET applications. So if I am given this task, I will sit with the development team and I need to understand things like what should be the run commands, because these run commands are required to download the dependencies and also to get any packages that are required to build the application. So I will go to the development team and ask them like what should be the run commands and what should be the entry point. Rest all things, I know to create a work directory. I know to copy the dependencies from the source code to this machine. And you might be wondering what are these arguments. So this is required when you want to build a multi-architecture or a specific architecture Docker image. So these arguments are basically for the target platform, target arch, and the build platform. So this is about the Docker files. Now what we will do is we will take this application into the Microsoft Azure DevOps environment or the platform, and we will start building the Azure pipelines. So the first thing is, of course, you need to get to the Azure DevOps platform. So in the last video, I've already shown you how to create an account with Azure DevOps. So we all have accounts with Azure DevOps now. One thing, it would be better if you have the same subscription for your Azure DevOps as well as Microsoft Azure. In this video, we are going to use the Microsoft Azure registry as well. So Azure registry will be in the Azure platform, and the CI pipelines that we are going to build will be on the Azure DevOps platform. You can also use Docker Hub if you're not comfortable. That is fine. So just pick up a project name. So I have deleted the last one. So let's start from the sketch. I will call it as voting application because I want to build it for this example. Voting app, an example voting application. And I want all of you to also try this out. Do you want to keep it private or public? Definitely I want to keep it private when I'm working in my organization. So create project. Okay, I think it is getting created. I just clicked on it multiple times. Now, the Azure pipelines can be used along with GitHub as well. So technically I can use it from here. I can just run the pipelines on the Azure board, on the Azure DevOps, you referencing this application from GitHub, but I want to do it fully on the Azure DevOps. So what I'm going to do is I'll go to the repos section and just go back to this, click on this particular button and copy the HTTPS URL. So I just want to use the Azure repos as well. Now, if you go to the repos, there is this option called import a repository. Let's click on this. Is it Git or TFVC? We are using Git. So let's pick this up and click on the import. Does not require any authentication because it's a public repository anyways. This will not take much time. Technically what it is trying to do, let me increase the font size. So technically what it is trying to do is it is taking the repository from GitHub and importing it to the private project that you have created on the Azure DevOps platform. And you can see that it is already in the Azure DevOps platform. But one thing you have to be careful is that the default branch, right? So Azure DevOps has picked the default branch alphabetically, whereas here the default branch is actually main. So main has the latest code always, and I want to build the CI pipelines for the main branch, not for the duplicate key. So Azure DevOps has picked up, the Azure repos has picked up alphabetically. So what I will do is simply I'll go here for the branches section and go to the main branch. Towards the right side, click on these three dots. And what you need to do is set as default branch, right? So I've set now main as a default branch. And if I go back to the repos, you will notice that the default branch is automatically set to main, and all the code, diagrams, architecture, everything is same as the GitHub repository now. So we are done with the first part where repos I already have. Now I need to create the pipelines. I need to create 3 pipelines. We are all clear with that. So click on the pipelines option. And before we create the pipelines, like I told you, I want to the created Docker image, I want to push it to the Artifactory, right? The Artifactory in our case is basically the Azure container registry, which is on the Azure platform. So let's go back to the Azure, right? This is my Microsoft Azure. And what I'm going to do is on my Microsoft Azure platform, I'll search for container registry. Like we can do it later as well. Of course, there is no problem. But just to go with the flow, container registry. And here I will just create a registry. You can also do it later, doesn't matter. So create container registry. Let me pick up a resource group. Let's start with creating a resource group. That would be better because I'm also going to use a self-hosted runner for my CI. So I'll use the same resource group for everything and later delete that resource group. So create a resource group. Let's call this resource group as Azure CI. So I'll just call it as Azure, let's call it as Azure CI/CD. East US is fine with me. I don't have a problem. And click on the create. Okay, it's still validating and the resource group is created. Now I have Azure CI/CD. Go back to Azure container. Search for container registry. And let me create a container registry. Resource group will be the same, Azure CI/CD. Name of the container registry. Let's say you need to choose yours. I'm picking up my container registry. So I'll call it Abhishek Azure CI/CD. Okay, so this is my registry now. And I'll pick up a standard plan. You can go with a basic as well, but let's go with the default. Anyways, I'm going to delete. Click on the create button. Initializing deployment. So my container registry is getting created. And let's move back. While this is getting created, I'll proceed with the next steps of my pipeline. So start with create pipeline. Okay. And which one should we do first? We have 3 microservices. So we are going to write 3 pipelines. So let's start with the results application. Click on the create pipeline. Sorry, results microservice. So we will pick up the Azure repo kit. We will not pick up the GitHub or Bitbucket anything. And this is the repository name. So we will choose this. Technically, you can choose any templates out of here, but the most relevant one for us today is build a Docker image or build and push Docker images to Azure Container Registry. What are these things? These are basically templates which will make your life more easier if you want to build on Azure pipelines. Then you have these templates. Like if I click on this one, most of my code will already be available. So I want to do build and push image to a Azure Container Registry. That's the reason why I have created a Azure Container Registry. Now, if you click on free trial, right? The previous step, why I created a Azure Container Registry is because of this one here. I know it is going to ask. So now it will try to establish a connection with my Microsoft Azure. These are 2 different platforms, right? And you should be able to see Abhishek Azure CI/CD. This is time taking one. Like if you don't see this one, don't think that something has gone wrong. Just wait for 10 minutes. Sometimes it takes a lot of time. And once you see this, you can proceed on validate and configure. Because I selected a template, you will see some of these code that is already given to me. But I will explain the complete structure if you want to write Azure CI. Basically, there is a structure where you have things like triggers, resources, variables, stages, right? If you understand these concepts, then you technically know how to write a Azure CI/CD pipeline, because these are the main components and these keep repeating. So this diagram will give a much better understanding. Basically, there are 4 things. One is trigger. Second thing is stages, jobs, and steps, right? Let's try to write them and understand. Okay, this is my cursor. Perfect. So we have triggers. So triggers is basically to say this pipeline, when should this pipeline trigger? if you're aware of Jenkins, then you either trigger it through webhook or you have a build schedule, build trigger, right? This is the same thing. This is a build trigger, which will tell the Azure pipelines that we are writing when should the pipeline be triggered automatically. Because these days, no one does it manually. No one goes to the CI pipeline and trigger it. So every time someone commits to the GitHub repository, this has to trigger automatically. And in today's video, what I'm going to do is I'm going to use some advanced trigger. This will be very useful for you, where what I'm going to do is, this is my example voting application. And in this particular project, there are 3 different microservices and we are going to write 3 pipelines. Now, what I want to do is on this repository, if someone makes change to this results application or results service, let's say they change the server.js, then I want only the results related pipeline to trigger. If someone makes change to the OAuth microservice, then I want only the OAuth microservice to pipeline to trigger. If someone makes change to the .NET application, then I want only the .NET related pipeline to trigger. So that is what I'm going to implement. And for that, what I will be doing is I will use this trigger called path-based trigger. And as part of this path-based trigger, I will inform that, okay, my CI pipeline has to trigger only when code changes are done to a particular path. It will be interesting. Just watch how I'm doing it. And then there is this stages. Stages is nothing but usually in CI/CD pipelines, we have stages, right? The build stage. Then we have, let's say, the image push stage. We have some end-to-end test trigger stage, deployment stage. These are the stages. And within each stage, obviously, we have, like, let's say if build is a stage, probably depending upon your requirements, within this stage also, you might want to run different jobs where this is, let's say your build is very complicated and you want to just write it in small parts. Then what we do is we execute it as part of jobs. And other advantage is that you can also dedicate one job to a what do you call it? You can dedicate one job to your runner. If your build stage has so many things to perform, then what you can do is you can split into multiple jobs and you can say one job can be executed on one runner, other job can be executed on other runner XYZ. Then within these jobs, we have multiple steps. And finally, we have something called as variables, which is something that everyone knows, right? Variables is when we want to pass things like you want to pass some passwords or you want to pass some things, you can read these variables from different sources. So now let's try to convert this into the CI pipeline. So trigger, like I told you, I will change this trigger to paths because I want to use a path-based trigger. So I can simply search for paths. Other triggers or branches, you can use all of those things. And here I want to include only one particular path, right? So just search for include. And in includes, the only path that I want to include is result. Because I'm writing this CI for results. Everything under the result folder, I want this CI pipeline to trigger automatically. This is something you can keep. Then these are the multiple variables that are populated automatically. And these variables are very important. Like we have this Docker registry service connection, which is for the connection between this Azure DevOps platform and your Azure container registry on the Azure platform. If you're not using ACR, that is Azure Container Registry, then you can ignore this part. If you're using Docker Hub, you can provide your own Docker credentials. You can read it from the environment. Environment variables is not good. You can read it from the environment section here, which can keep your details secure. Then image repository within the container registry. So I'll keep this one as a result app. Right? This one I'll keep as result app. Next microservice CI that I'm going to write, I'll keep it as voting app. And for the next one, I'll keep it as worker app. Container registry, this will be same for all my microservices. Docker file path. Yes. So it is under result folder. So the Azure pipelines are intelligent enough to pick up one of the Docker file. Ideally, there are multiple Docker files, so it just picked up one Docker file. And luckily, in our case, this happens to be the right one. So I'm writing this for the result service, so I'll keep it. And also I can rename this. What I will do is I'll call it as Azure Pipelines result.yaml. Perfect. Build the number, I don't mind. And this is a very important one. I'll come back to this. Basically, what is this doing is this is the agent where this entire CI should run, right? If you're using Jenkins, then you will create your own worker node or the slave node, and you want your Jenkins pipeline to run on it. Similarly, for Azure pipelines also, there are two options. One is you can create your own slave or agent, and you can run your pipelines on top of that particular agent, or you can use the ones that Azure provides you automatically. If you use the ones that is provided by Azure, then you don't have to maintain those slaves and all. But unfortunately, at this point of time, Azure does not provide you these things on a free trial account. If you are using a free trial account, better you create your own agent, and all that you need to do is say pool name, and what is the name of your agent that you are going to create. Let's say we will create an agent called, let's call it as Azure agent. So what I'm going to do here now, once I explain you the complete file, what I will do is I will go back to my Azure, right? I'll go back to my Azure, and here I will create a virtual machine, and these pipelines on the Azure DevOps platform will run on my Microsoft Azure board portal on the virtual machine that I'm going to create. So this virtual machine is going to act as an agent for my CI pipelines. Perfect. So we will create this. We haven't created at this point of time. Then the build stage. Right now, what does the build stage has? So the build stage has, it says build and push stage. I want to split these things into two. I don't want to have a common thing for build and push. So I'll just take this out. Job is build, perfect. Display name is build. Pool, like I told you, let's remove this one because on the free trial account, it is not available anyways. So here comes, these things are very important, where what you want to write inside the steps. That is, what steps do you want to perform? In this, the step that I want to perform is the building of this application. For that, we have this task. If you remove this one, you can write any kind of task here. Like I want to perform a shell script, then just search for shell. You will get the shell script related task. We actually want to build a Docker image. So if you just search for Docker, pick up the latest one, Docker@2, and click on this settings button. Right here, you have what exactly you want to perform. Do you want to perform build and push? Like I can write all of these things, but when you are writing for the first time, definitely use this thing. And later point of time when you write, you can write it without looking at it. But I don't recommend it that much, because even during the interviews, you should be able to explain the structure, but nobody bothers about the complete syntax and exact commands. Because in this world where there are multiple CIs, it is practically impossible for someone to remember the Azure CI pipelines exact syntax, GitHub Actions, GitLab, Jenkins, Circle CI, Travis CI. There are hundreds of CIs, right? It's a wrong expectation if someone expects that. I want to only perform the build, right? So let me change the command to build. Push, I want to do it as a different command. And where is my Docker file? It's inside result. Do I need to change anything else? No. Click on the add button and it will automatically change. Then I will add a new stage. Let me just copy this one. And this new stage will be the image push stage, right? Where I'm going to push the Docker image that I'm going to create. Let me just change this display name to push. This also I'll change to push. This also I'll change to push. Push the image. Similarly, I'll say build the image. Perfect. Now, I'll just click on this settings button because the task is again a Docker image related one. So I'll keep this Docker@2. and I'll click on the settings button. Here, I'll change the build to push. That's it. That's all I have to do. So I'll change from build to push, and all the related code is directly provided. If you're using Docker registry, then you also have to perform something like Docker login first, because automatically, because I am using Azure platform related registry, so the connection is established. Otherwise, you have to take care of those things. We will learn that in future classes where we will also use Docker registry. But to start with basics, let's use the basic way. So I have the build stage, I have the push stage. We can also add the test stage, but let's start with build and push first. Okay. Now, if you click on save and run, you will notice the error that I was talking about. Obviously, when I do this save and run, pipeline is not valid, cannot find a pool with name Azure agent. That is because we haven't created this agent at all, right? Now let's go back and create the agent. For that, what I have to do is Azure, virtual machine, and I'll use the same resource group for the virtual machine as well. So let's say Azure virtual machine. So resource group will be the same. Azure CI/CD is the resource group. Let's call it as, what did we choose there? We choose something called Azure agent, right? Let's copy paste the same thing. Availability zone, I'll keep it the same way. SSH keys is very important because we have to log into this agent and perform some commands. So let's use SSH public key, or you can use the password as well, whatever you would like to. I'll use the SSH key itself. I'll call it as Azure agent underscore key. We can also rename it. I think I have another Azure agent. So let me call it as Azure agent one underscore key. SSH public key. If you have existing key pairs, you can also use them. That is not a problem. I don't want to change anything else. Let me quickly check. Perfect. I don't want to change anything with the networking. So click on review plus create. Now, once this virtual machine is created, how to integrate this virtual machine, because this is on the Azure platform and your pipelines is running on the Azure DevOps platform. So there has to be a connection, right? If this pipeline has to run. So for that, there are some commands. How do you get that commands? Basically, you can just go to this Azure DevOps documentation. Just search for Azure DevOps pipelines docs. Click on the first link that you will see. And here, what I am going to do is just search for agents and pools. It will be somewhere. Let me just find it. Agents. Yeah, manage agents and agent pools. And here, if you scroll down, let's use a self-hosted Linux agent. Ideally, if I was not doing this demo, I could have actually run it on my Mac laptop as well. You can run it on your Windows laptop as well. But, I want everyone to understand. That's why instead of I doing it on Mac, you doing it on Windows, I thought we will create a virtual machine and we will execute the same commands. Otherwise, you can also do it on your machine. Okay. So this document explains the steps very clearly. Okay. What we need to do is we need to perform some steps which are illustrated in this document. So for that, let's go back and see if my virtual machine is created. Oh, sorry, I did not click on the create button. So now I clicked on the create button. Download the private key. So the private key is downloaded and the virtual machine is also created. So meanwhile, let's understand what are the commands that we need to run. Right. So here it is telling us, firstly, go to your Azure DevOps organizational settings. Okay. So let's go back to our Azure DevOps board. And towards the downside, we have something called as organizational settings, right? So here we have this project settings. And if we click on this project settings, just search for agent pools. So this is the agent pools. And here, what you can do is you can click on the add pool. And you want to add a new pool? Yes. So I want to create a self-hosted one. That is, I want to host it myself. What should be the agent pool name? Again, let's call it as Azure agent itself. Let's use the same pool name. Pool for running my Azure pipelines. Grant access permission to all the pipelines. It's fine. Click on the create button. So now this is my Azure agent pool. Or otherwise, you can also pick up the default one. Anything is fine. I think there will be some configuration issue because I already have the similar one on my default pipelines. So what I'm going to do is I'll just delete this default. So now inside my Azure agent, when you click on this one, click on the agents, click on the new agent. And depending upon your virtual machine that we are using, in our case, we are using a Linux virtual machine. So let's copy this. We will copy these commands and we will run it on our Linux virtual machine. So let's see if my virtual machine is ready. It should be ready by now. Perfect. Go to the resource. And within this resource, now let me pick up the public IP address of it. Copy the public IP address, right? Let me bring my terminal on. And we will just follow the instructions that are provided here, right? So terminal SSH -I. If you're on Windows, a lot of people ask me this question that on Windows, we are not able to perform these commands. Very simple, use git bash. Okay, once you use git bash, go to your downloads directory. Okay, cd $downloads. In your case, wherever is your downloads, go there. Then run this command SSH -I, wherever, whatever is your PEM file name. In my case, it's Azure agent, I guess, one. Yeah. And Azure user @ the IP address. Click on the yes. PEM file permissions denied. Run chmod 600 followed by your PEM file name. Same commands on Windows as well. Please don't get confused. Doesn't matter because the terminal, we are just running the SSH command, right? Now I am on my terminal. Let's run the same commands. And here, just be careful. You know, these ones that you see, you should not copy them. Start from mkdir. I'm just talking for the beginner's point of view. Some people might not understand that. So that's why I'm talking about it. Copy this URL, wget, run the command. And because this is a new system, we should also do sudo apt update to update the apt repositories, right? So I think the repositories are updated. Okay, one more second. Once the repositories are updated, let's copy the next command. That is to extract the binary. So here we have the tar file. Let's extract the tar file. What does it say? It says, did I copy something wrong? So here is the tar file. And what did it say? Error is not recoverable, existing, cannot open such file. Okay. So, you know, it's actually searching for the downloads folder. So we'll just remove this part. That's why I'm saying do not copy the commands directly. Perfect. Now the tar file is also extracted. Then it says run the config.sh. Run it. This we have to run it, create only once. For all the pipelines, we just do it once. Don't worry. Enter the server URL. What is the server URL? Just go back to the documentation, right? Where is the Azure documentation? So here they provide you the server URL. All that you need to do is just copy this one, and it says your organization. So what is my organization in this case? On your Azure DevOps, the project that we are working, OTing app, is not the organization. My organization is Hello DevOps Aspirants. Sorry, Help DevOps Aspirants. So Help DevOps Aspirants. Enter the personal access token. So we need to create a personal access token. Again, to create a personal access token, go back to your Azure DevOps. Where is that? Yeah. So we will go back to the Azure DevOps user settings. I think it will be somewhere here. Let me try. Yeah, personal access tokens. And what you need to do is click on create a new token. Just provide it for 30 days. I'll give full access for now. I'll delete the access token. So whenever you are giving full access, make sure you delete it after the demo. Let's call it as Azure agent. Create the personal access token. Warning, make sure to copy the agent token. Yes, I will copy the agent token. And now it says press enter for PAT. That is the personal access token. Yes, I want to use the personal access token. Now it says enter personal access token. Now it will try to establish the connection and see, right? Because it has to establish the connection between your Azure DevOps and this thing. Now enter agent pool. So what is my agent pool in this case? The one that I've created. There are so many tabs. So okay. So the agent pool that I've created, I guess if we go back to Azure DevOps organizations, it should be Azure agent, if I'm right. So let's see in the agent pools, the one that I've created is, yes, small Azure agent. So let me type that AZUREAGNET. Now again, it tries to establish a connection. Let me pull this down. Press enter for Azure agent. Enter agent name. Agent name is also the same thing, right? If we go to this, so the agent name is also where is this? So the agent name is also Azure agent. So let me type that. Scan successfully added the agent. Okay. So now it says enter work folder. Press enter. I think it is fine. Now let's save it. Perfect. So Azure agent is added. Now if we go back, agent is offline because what I have to do is I have to run two commands. One is config.sh. So just say /config.ls /config.sh. Cannot configure the agent. To reconfigure the agent, okay, what happened? Let's see. Cannot configure the agent because it is already configured. Okay, let's see by running /run.sh. Or do I already have the agent with the same name? Probably that is why it is talking about it. Let me go back to the default agents. Let me delete this and try. Let me try one more time by running /config.sh. Okay, let's try run.sh. Dots. In your case, probably you might need to run configure.sh. So now it is saying listening for jobs. So probably if we go back, we should see the agent as running in our case. agent pools, Azure agent, agents. Perfect. It's online. So now our agent is ready. But one thing that I have to do is I missed that part. Basically, we want to run the Docker thing, right? Our images are Docker images. So this particular machine should have Docker installed. So let me stop it once and install Docker sudo apt install docker.io. So I forgot to do this part because we are doing Docker images. We need to do this. Docker needs to be installed on the agent. Perfect. So I think this is going good. Once the Docker is up and running, then what we also need to do is grant the Azure user permissions to the Docker daemon. Because we have configured the agent with this particular user called Azure user, that is the default user on this machine. So if you were using the root user, then we don't have to, but I'm starting the agent with Azure user. So that's why what I will do is sudo usermod -ag. Then I have to add it to the Docker user, Azure user, right? This is the Azure user. And now what I'll do is just say sudo systemctl restart Docker. Now I hope this will work. Let's see if there will be any issues. We'll try to fix it. Let's go back to our Azure pipeline. Let me start the agent back, run.sh. So I want to make sure my agent is always running, connecting to the server, listening for the jobs. Perfect. Now I'll go back to my pipelines, Azure pipelines. Here, the voting app, last time it failed. Now I have an agent. Let me run and see the pipeline. I hope it should run. See, there are two stages. This is what I was talking about. It will clearly show us. This is the build stage. This is the push stage. We can add test stage, unit testing, static code analysis. Any number of stages we can do it, but these are our primary stages, right? In the particular repository that developers has given us, there are no unit tests. Okay, what did it say? It said permissions denied while connecting to the Docker daemon. That means there is some issue that still Docker is not accessible by the Azure user. Let's see why. Sometimes it is good to connect back. So what I will do is I'll log out from that instance and log in back. It works sometimes because we have just granted the permissions to the user. And now I will just do it one more time. System CTL restart Docker. And for that, what I will do is I will do sudo. We will do a verification by running Docker pull. Let's pull hello world and see. Now it is able to pull. That is, Azure user is able to access the Docker daemon. I hope it works. Run.sh. It's in the folder called my agent. Then we need to start the agent, right? Run.sh. Now I hope it works. Again, if it does not work, let's see what is the error and try to fix it. Run new. I'm just trying to run it one more time. So we can also open this and see how the execution is going on. Build is pending. Job is pending. So maybe we will run into that error again. If it occurs again, then probably I'll also grant some access to the Docker related binaries. Now it is trying to pull the Docker image, right? This is a Docker file that we have, and it is trying to pull the Docker node. This is the results application, right? Oh, it's working fine. Perfect. So I restarted, I just logged back to my virtual machine, logged out, logged in, and I granted access to the Ubuntu user. Did it pass? Let us see. So it said recommended predictions disabled. That is fine. So the Docker image is still running. If the build image is done, then okay, the build stage is successful. Let's go back to the pipeline and see if both my build and push are successful. Okay, now push is running, build is successful. So this is the voting application. There were 3 runs that we tried to perform. The first run was totally wrong. Second run, we had issues with the Docker, right? And third run, we are successful. So both the build stage and the push stage, both of them are successful. Perfect. So we are done with one microservice. Now, similarly, we will have to create for the other microservices, right? And let us also do that verification. I told you, if I make any changes to the repository here, now let's try to make any change to the worker. Let's go to the worker folder. Let's go to the Docker file and let me add one extra space. Okay, I'll just add one white space. Edit and add one white space, commit. And now I don't want the CI to run automatically because the change is in the worker. Let us see if that goes well or not. Now, if I go to the pipelines, this should not trigger automatically, and it did not trigger. Now let's go to the repos. And what I'm going to do is now I'll go to the results, and within the results, I will try to modify server.js, and I'll just try to add a new line here. Click on the edit. Let's add a new line here. Commit. And now I want my pipeline to trigger automatically because this is the results folder. Let's see if that works fine. See, the build got triggered, and now the build is running also. You can also check that on your worker. So on your worker also, it will show that some build is going on, right? So that's a great progress that we have done. Now our job is to just create these things for the 2 other microservices so that we will be done with our CI stage. Adding extra steps, it's very simple. Right now, this repository does not have unit tests. So that's why I did not add the test stage. But if they have the test stages, then all that we need to do is add one more stage. So that's not a big deal. But in our case, let's add 2 more pipelines. And 2 more pipelines also, I want to add it in the same way, where results will only trigger results and .NET will only trigger the .NET related pipelines. Voting app, and this time again pick up the same configuration because technically we are going to do the same thing. Last time I did it only for one pipeline, so a lot of people asked about it. So that's why this time I'm specifically doing for all the microservices. Container registry is going to be Abhishek Azure CI/CD, validate and configure. Configuring resources and generating YAMLs, the same configuration that we saw. Perfect. Voting app. Now, this one, last one, I think we used for the result app, right? Now this one, let's use for the voting app. And let me call this as, rename this to vote. .NET one, we will rename to worker. So triggers, here the trigger has to be paths, and within the path, the trigger should include only vote. Right? Last one, if I take this in a new tab and show you people, right? If we take repos in a new tab, the last Azure pipeline that we wrote, Azure pipeline result. So here clearly the folder was result and the name was Azure pipeline result. Here the name is Azure pipeline oat, folder is oat, and we will do the exact same configuration. We will remove this section. We will call pool. This is what I was talking about. If you write one particular YAML file, next one becomes a cakewalk. Azure agent. So now immediately, because I have past experience, the one that I wrote right just 5 minutes ago. So build and push stage. No, it's just a build stage. Build an image. Remove this part. Build. Task is Docker. Let me just quickly change this to only build. And here I'll say oat Docker file. Add. Immediately copy this. See, we are writing this in less than couple of minutes, right? And I'm pretty sure this will work because almost the structure is same all the time. That's how the CI is very easy. You just need to know the concept. That's it. Now I'll call it as push stage, push, push. Just change the settings and here just call it as push. Add, right? So image repository will change automatically because previous one was result app. Now in the image repository, we have given result app. You can verify this on your Azure registry also. On the ACR repository that we created on the Azure platform, you can go and you can check these repositories, or otherwise you can also log in on your personal laptop to the Azure registry and you can also check. Logging into the Azure registry, there are few commands. There you just have to run the command docker login your Azure registry URL and provide the username and password. That's very straightforward. I'll show you. So the voting app, perfect. Azure agent. Now, I think this is good. I clicked on save and run. That's why it's going to run, right? I have forcefully triggered it. Otherwise, this wouldn't have run because I haven't made any changes to the voting directory. But I clicked on the run button explicitly. That's why it is running. And I hope this will also be running successfully. And same thing we will do with the worker configuration also. So if this succeeds without any error, then the worker one, let's take as an assignment because I have shown you two microservices, one microservice, exact same configuration, try it by yourself. If this has any issues, I'll definitely do the other one also. But if there are no issues, technically it will be the same one for the other microservice also. So you can proceed with that part. So it is still running. Let us see what is happening in the logs. So Docker build is going on. Build image is successful. Let's go back. Pipelines. This is the one. It is still running. You can also rename this one. If you click on this options here, rename, and let's rename the previous one to results service, result service, and let's rename this pipeline to port service. Right? So port service is still running. Maybe if there is some issue, I guess, let's see. Oh, this is also successful. So result service is done, port service is done. Let me quickly do it because last time when I missed one service, a lot of people were confused. So technically we will do it in less than a couple of minutes. So I'll use the same configuration. You can also copy it. That's other way of doing it. You can copy the Azure pipeline.yaml, but just that you will get used to. That's why I'm doing it from the console. Same registry. And don't forget to delete all the configuration, delete from Azure DevOps and also delete from the Azure. Try to delete everything. And this time I'm going to do it really quick because the entire configuration is same. Let's not waste the time unless there are issues. If there is any issue while the execution, then I'll do it. Generating the YAML file. So what are the changes? Go to the trigger, In the trigger, go to the paths. In the paths, include a particular path. Just say this time worker, and this will same. This will be worker app, and let's change the name to Azure Pipelines hyphen worker pool. What is the name of the pool? Name of the pool is Azure agent. Let's remove the pool from here. Otherwise, it will try to run on the uh, Azure agent. And for the free account, we don't have access to it. So build settings. Let's change this to only build. Path is worker.file. Add. Let's only write the build stage for now. Save and run. Right? And even for this, we can go back and change the pipeline so that our pipelines are very clear. Right? This has to be edit. Oh, sorry, my bad. This has to be renamed to worker service. So this is how what we have done in today's task is we have completely migrated the GitHub pipelines to Azure pipelines. So you can add it to your resume also. Experience migrating GitHub CI pipelines to Azure CI pipelines. So we have totally migrated, right? All our pipelines now are running on the Azure, and our repository is also migrated to Azure. So you have technically done GitHub to Azure migration 100%. I mean, with respect to the pipelines and source code. Okay, this failed. Let us try to see why. I think we missed something. Deprecated. What did it say? Failed to parse. Where exactly? Build and push an image to container registry. It says an invalid argument in the platform specifier. And here, let's go to the worker, go to the Docker file, and see, this is where it is actually failing. Right? Needs an input for the platform, right? So if we are not providing any input here, then it fails. So what we need to do is just replace this platform with Linux, ARM64 or V8, right? So if you provide this information, whatever is the input that is required. So let's pick up anything. We can go with Linux or we can go with ARM64 or V8. So let's just change this one to Linux and see if it works, right? Because my target environment is Linux. So let's see if this particular change will bring any difference. Because I changed it to the worker directory only, I'm expecting the pipeline to automatically trigger. Yeah, it is triggered, which is another use case for us. And okay, going back to what I was saying, if this is also successful, then it will be a very good project for the resume to say that migrated complete GitHub to Azure pipelines along with the source code as well as the pipelines. So this time I'm expecting it to pass. Let's see. Let's go here. Is the Docker file building? See, it automatically picked our platform change. If you see here, now it picked up from platform is equals to Linux. So that was the change that I've done, but still I think it failed. Let us see why. Okay, there is another environment variable which is called target arch. So again, I have to go back and because those things are passed as environment variables in the GitHub repository, either I need to pass them as environment variables here or the one that I'm doing. Better we actually pass it through environment variables, but right now we can just change it. Let's let's see if that works. Go back to the pipelines. Okay, I think now we are going to enter to that particular stage. Yeah, so I think it's running fine now. I hope so. But we removed the multi-architecture part. So yeah, so I removed the architecture build part. So what I need to do is I need to go back and figure out how to add that particular command to run it on a particular architecture. Right now, what happens if I remove that particular thing, it will by default run on the Linux thing. And the architecture that this Docker image got created also for the Linux part. So I'll go back and see how to do that for the .NET applications and probably share that on our Telegram. But for now, I migrated the GitHub application completely to the Azure pipelines. So take yourself a pat if you have also done this, if you're doing it parallelly with me, or if you're going to do it, because this is a very interesting project. In tomorrow's class or the next class, whenever we are going to do it, we will implement the CD part for it. So CED is going to be fairly simple, I guess, but I'm not sure what challenges we are going to face. But because the CI is done and the containers are also getting created, these containers are uploaded to our Azure Container Registry. So I hope pulling those images from the container registry and deploying it to a virtual machine, which we will do, shouldn't be that difficult. I'll show the rest part of the CD in the next class. Thank you so much for watching the video. I hope you all enjoyed it and see you all in the next one. Take care. Bye-bye.